What is big O notation and why is it important? In this video, I'm going to show you just that. Up here, we've got our animals array. And within our animals array, we have two additional arrays, index 0 and index 1, containing different breeds of dogs in index 0 and different breeds of cats in index 1. So if I were to loop through this original animals array, calling them breeds in animals, and then just simply print the array that's in each index, so print breeds, it'll give us an output that looks like poodle, pug, corgi, all in one. And actually, I think in Python it just takes this straight off. So it would look like that. And that would be an example of an ON algorithm as you're looping through each item in an array. But if I were to change this and add a second for loop for breed in breeds, and then within this loop, which is our second loop, then print the breed, the output of this would go through this original animals array and then go to the first index, and then within that first index, it's going to pre-print separately poodle, pug, and corgi, and then go to the next index and print Persian, etc. It'll keep going through and finish all of them. And that would be an example of what we call ON squared. The original one without the second loop in there was just ON. If we were to just say, you know what, we're not going to loop through it at all, and just look at this animals array and just print this original array, I'm not sure if that would execute, but that would be O1 because there's no loops in it at all. It's important for, as you can see over here, we've got n items as their x-axis and time as our y-axis. And for it to be more efficient, you obviously want to reduce the time. And the more loops you have in a program, the more times there's loops within loops, exponentially increases the amount of time your algorithm will take. So, for example, O1 is constant time. So that means it's not looping through there's no loops, so it's not having to loop at all. So it'll look something like this, just straight following your x-axis. And ON is going to look like the graph y equals x, or just a straight line. And further, ON squared is going to look like a parabola. And as you can see, the higher the degree on our n, the more time it's going to take to go through our items. And then finally, ON cubed is here. To keep your program short, you want your degree on your n to be as low as possible, and ideally you're looking for ON. O1 is rare and no higher than ON squared. And it's worth noting that if we were to go and do this two loop example twice, it would be O2n squared, as you're having to go through an n squared example twice, and the amount of times you do that is just increasing the leading coefficient. But really what's important is the leading coefficient doesn't matter, just the degree on the end.